Good morning. Welcome to today's discussion on wireless internet. Of course, wireless has become a buzzword nowadays because we are able to have a seamless connectivity wherever we go, and we know what internet is. Internet basically is a technology that has actually paved way to network different people across the globe and try to exchange information globally. And we are just going to understand what exactly wireless internet is in today's session. What is a wireless internet? Wireless internet refers to the extension of the services offered by the internet to the mobile users. So as I said, we know what internet is. We know that the wireless technology has actually taken up today's communication. So this wireless internet extends the services that is actually offered by the internet to the mobile users. Whenever we say that we try to have a transition from one existing technology, we of course will face certain issues. So there are certain issues that is actually have to be addressed for actually extending this internet to the wireless part. So one of the issues is about the address mobility. So we know that the traditional IP address does not support address mobility. So addresses assigned are going to be fixed. So we need to understand that at the network layer, there must be some solution that we try to propose to address this mobility issue. And mobile IP is going to be a solution, which we will try to discuss subsequently in our further slides. And the next issue is about the inefficiency of the transport layer protocols. The normal tendency is, like whenever we talk of TCP, it always comes to our mind about the congestion that is going to take place. It is generally interpreted that whenever a congestion happens in TCP, it is because of the loss. The loss in data is just because of the congestion. And we try to interpret them that TCP is always trying to falsely identify that the loss is because of congestion. But the fact is, it can be also because of the transmission errors, right? And which ultimately reduces the transmission rate. So there are certain methodologies again that we have tried to present, which will try to overcome this inefficiency in the transport layer protocols, such as indirect TCP approach, a Snoop TCP approach, mobile TCP approach, and so on. Similarly, when we get to talk about the application layer protocols, we know that we have the traditional protocols like your HTTP, that is nothing but your hypertext transmission protocol, and your SMTP, which is a simple mail transmission protocol, which are typically designed for the wired networks. When we try to extend them, probably bandwidth is going to become the maximum, limitation that we'll have to address. So we need to actually pave mechanisms to identify other protocols which would actually support wireless. So WAP is again a solution that has been proposed for application layer issues. So mobile IP at the network layer, indirect TCP or a Snoop TCP or a mobile TCP at the transport layer, and the WAP protocol at the application layer are actually the proposals that have been identified to address the issues in the existing networking. Right. So further to this, there are also certain other issues such as compatibility, transparency, and scalability. So whenever we try to have an upgradation, we know that we need to have the integration that will have to exist with the present OS, and it will have to be compatible across all the lower layers also. And when it comes to transparency, of course, the mobility part should not be visible to the higher layer protocols, which should be handled by the lower level protocols. And scalability, whatever technology it is, we need to scale up to more number of users. So support to scalability also plays a major issue which needs to be addressed. Right? Fine. What is the motivation for this mobile IP? Why is that we have to go ahead extending the internet protocol to support mobility? Right? So the goals, as I said, one is to add mobility support to the internet network protocol. The other one is we'll have to support location independent routing of the datagrams in the internet. Right? So to achieve this goal, of course, there are certain ways that have been devised. There are two ways that we are going to understand now. One is we are just going to change the IP address whenever the host happens to move from one network to the other network. But what would be the effect on this is the connection that we'll have to have for the TCP itself may have to be re-established. So that may become a big drawback. And the next methodology or the way that we try to understand is about to use the same address which is existing and add some special routing entries into the routing table. Right. So what would be the issue with this methodology is, see, the number of users, if they become very large, then the number of information or the details or the entries that we'll have to maintain in the routing tables are also going to increase drastically. So maintaining the routing table may become an issue, right? However, we need to strike a balance to understand that we need to adopt one of these ways in order to extend this to the mobile IP, right? So what exactly is mobile IP? The mobile IP or IP mobility is designed to allow mobile device users to move from one network to the other while maintaining the permanent IP address, and on adding some additional mechanisms. So in all the further discussions, we are just going to see as to how this additional mechanism is added to support mobility by using the same permanent IP address, right? During the course of discussion, we'll come across this terminology called as a care-of address. I'll try to explain more on this. And there are also other terminologies that we need to understand. So before we go ahead, let me just tell you about what a tunnel is. So a tunnel basically is a virtual pipe that is going to be created between a home network and a foreign network. So what do I mean by a home network? Assuming a mobile user who has tried to register with a particular network, the registered location is what is called as the home location. So the credentials of the mobile user is maintained at the home location, in the location registered and so on. And when this mobile user happens to move to a different network other than his home network, we call that network as the foreign network. And this foreign network, whenever a mobile user becomes associated with it, it has to actually share some details about the new mobile nodes who have actually become a part of the network. So we'll try to understand what they are. So a virtual pipe that is basically created between the home network and this foreign network is what is going to be a tunnel, and a special address is going to be assigned to the end point of the tunnel, which is called as a care-of address, right? So this care-of address is basically used to identify a mobile node when it is not associated in the home network and when it is now in a foreign network, right? So with this fundamentals, let us try to understand certain terminologies that we need for the subsequent discussions. One is about the mobile node. So a mobile node is just a system that can change the point of connection to the network without changing its IP address. So this is very important. Home agent, as I said, this is a system in the home network. So it is an agent that is trying to maintain certain details about the mobile nodes in the home network, which is nothing but the permanent address. And this home agent is nothing but a typical router. Okay. And as I said, it's just going to register the location of the mobile node with the help of a main location register. And whenever a packet is actually intended for this, it will try to tunnel the IP datagrams to the care-of address. Okay. So the next one is about the foreign agent. This is basically the system that is in the current foreign network of the mobile node. So this is also typically a router. And again, this forwards the tunnel datagrams to the mobile node, also called as the default router for the mobile node when it is in the foreign network, and stores the information about the mobile nodes whichever tries to visit its network. Right. And I already told you what a care-of address is. So it is just the address of the current tunnel, that is a virtual pipe that is created for forwarding the data packets. Or it can also be called as the termination point or end point of a tunnel towards the mobile node. And this care-of address at times can be actually chosen via the dynamic host configuration protocol also. I'll try to tell you how these variations are actually addressed in the subsequent slides. And the other terminology is a correspondent node. So a correspondent node is nothing but a communication partner. And tunneling is basically the home agent that encapsulates the data packet inside another packet addressed to the care-of address of the mobile node. So we'll just take a simple example network and see how this tunneling is happening. Right. So with the example network, let us recall all the terminologies that we have gone through in the previous slides. So this is what I called as a home network. We have a home agent. The home agent is nothing but a router, a typical router which plays a role of a home agent. So we call this as a physical home network for the mobile node. So what do we mean by a physical home network for the mobile node? This is where the mobile node has actually registered to, and all the details about the mobile node is maintained by the home agent, right? Then, as I said, you have a correspondent node. A correspondent node here is an end system, and it is just going to be a communication partner which will try to communicate with the mobile node. And you have a router to connect with the rest of the internet. And this is the foreign network. And what I meant as a foreign network is, whenever a mobile node is away from its home network, the network with which it is associated presently is called as the foreign network, right? And this foreign network basically becomes the current physical network for the mobile node because it is present in the foreign network at this point of time, right? And this is the foreign agent. As I said, this foreign agent again maintains the details of the mobile node, whoever is actually available in its network. And we understood about a tunnel. So a tunnel is nothing but, as I said, it's a virtual pipe that is going to be created between the home agent and the foreign agent. Okay. So before we go ahead, we understood what a care of address is. As I said, it's an address that is assigned to the endpoint of the virtual pipe or the tunnel. So if a mobile node determines that it is connected to a foreign network, it acquires a care of address, and this address basically is acquired with the help of certain messages like advertisement messages. It is actually generated by the agents, right? So there are two types of care of addresses that basically exist. One is called a care of address acquired from a foreign agent. The other one is a co-located care of address. So we need to understand the difference between these two addresses. One is care of address acquired from foreign agent, and the other one is co-located care of address, right? So first, what is care of address acquired from a foreign agent? So a foreign agent care of address is an IP address assigned to a foreign agent that has an interface on the foreign network being visited by the mobile node. So this is very important. So whenever there is an interface available on the foreign network, we call it as a foreign agent based care of address, which has been acquired from the foreign agent. And the other one is, it is a co-located care of address. Co-located care of address basically is assigned whenever there is no any foreign agent that is available in the foreign network. Then we would be wondering as to how a care of address would be assigned without any foreign agent. So here we try to use the mobile node itself as an interface, and an IP address that is temporarily assigned to the interface of the mobile node is basically called as the co-located care of address, right? So each mobile node in the foreign network is assigned its own care of address, and as I said, it's going to be done with the help of your DHCP server, right? So we now understand what a foreign agent based care of address is and what a co-located care of address is. To understand more, let us take a simple example, right? So assuming that Mr. John Smith, who actually is a registered user of London, is at present in Tokyo, right? And if there is any letter that has been posted to John Smith, probably it's going to be posted to London's address. So when the London's post office receives this letter, then they try to encapsulate it and send it further to Tokyo's post office, right? So the London personnel would take the letter for John Smith, send to his London address, and repackage it for delivery to John Smith, care of the Tokyo's post office, right? So this is what you call as the foreign agent's care of address, and the Tokyo's post office takes the responsibility to actually deliver it to John Smith, right? So this is how a foreign agent based care of address is assigned, and the mobile node, whichever is going to be in the foreign network, is going to be delivered with the data packets, right? Coming to co-located care of address, this is something like this. When John Smith obtains a temporary address for his use while he is in Tokyo, London post office would just forward it directly to its Tokyo address. So it doesn't actually take any specific steps to actually forward it. So it is just directly going to send to his address. Instead of sending it to Tokyo's post office, it's going to send directly to Smith with his temporary address that he is using in Tokyo. This we can very well relate as to what happens with us when we try to use a mobile number that is registered in India, and if at all we go to a foreign country, how do we get a temporary address and we try to connect to our home network and talk to our friends and relatives. So that is the typical difference between a foreign agent based care of address and a co-located care of address, right? So if these concepts are clear, let us now understand how the data transfer is just going to take place between the correspondent node and the mobile node. And this communication we are just going to understand assuming that the mobile node, who is a registered user of a particular home network, is at present available in a foreign network, right? So the procedure is actually like this. You can notice that the correspondent node will try to send the data packets addressing to the IP address of the mobile node. So the data packets actually traverse through the internet. And since it is with the IP address of the mobile node, it is naturally going to be delivered to the home agent. The home agent, when it receives this, since it has actually had the details that has been communicated by the foreign agent about the credentials of the mobile node at present, the home agent is able to now intercept the packet, encapsulate it again, and tunnel it across towards the foreign agent. So the foreign agent, on receiving this, decapsulates it and further tries to forward the packet, giving the details as correspondent node's address to be the sender's address and the mobile node's address as the receiver's address. Now what is the key concept here is the mobile node mobility is not visible to the correspondent node at all. The correspondent node believes and imagines or understands that the mobile node is very well available in its home network. So the mobility aspect here is completely hidden to the correspondent node. So this is the improvisation that have been proposed. Using the permanent IP address, we are trying to encapsulate and try to assign an address called as a care of address. So this is the tunnel that has been created. The red lines that are given over here is the tunnel that is created, and a care of address that has been assigned to this tunnel endpoint has actually been encapsulated by the home agent to be delivered to the foreign agent, where the foreign agent has decapsulated it and used the original address of the correspondent node and the mobile node to have its communication extended for delivering the data packets. Right? So this is the data transfer that is happening between a correspondent node with the mobile node, where the mobile node is in a foreign network. How would it be in the vice versa? Now the mobile node is now interested to send some data packets towards the correspondent node. So if you notice, the mobile node tries to send it to the foreign agent. The foreign agent just tries to forward it via internet towards the correspondent node. So here the foreign agent works as a default router and forwards it to the correspondent node. So here it doesn't have any encapsulation sort of, because the correspondent node is still available in its own address, right? So this is data transfer that happens from the mobile system to the correspondent node, right? So let us now try to understand with this simple scenario as to how a data path for foreign agent care of address has been assigned and the data path for co-located care of address has been assigned, right? So when we look at this slide, so we understood that we had a correspondent node, a home agent, and this is the tunnel that is created. So tunnel and the virtual pipe are synonyms, so we can use them alternatively. So a tunnel that has been created, and this is the foreign agent to which a care of address is assigned to the interface. So this is a care of address which is given based on foreign agent based addressing, and you have the mobile node. So what happens to the data packets is the correspondent node, when it tries to actually forward the data packets, it tries to give its address as the source address, that is the correspondent node's address as the source address. The address of the destination here is the mobile node, so the address of the destination is given as the destination address, that is the mobile node's address, and this IP packet is actually forwarded by the correspondent node to the mobile node. But since the mobile node is not available in the home network, the home agent receives this packet and it tries to do an encapsulation, as I told you in the previous discussion, where encapsulation actually happens such that the data packet that was sent by the correspondent node is now covered with the address of the home agent as the source address, and the address of the destination as the care of address, right? So this encapsulation happens here at the home agent, and the packet is actually forwarded through the tunnel. When the foreign agent receives this, it tries to decapsulate. So on decapsulation, we mean to say that the home agent's address and the care of address are removed, and the actual address of the source is actually used to send it subsequently to the mobile node with its address as the destination address, right? So this is what has happened in the data path that has been created for foreign agent based care of address. Now coming to the data path for co-located care of address, again you can notice that we have the correspondent node, we have a home agent, and here you should notice that a virtual pipe is there, then a foreign agent is missing. So when a foreign agent is missing, a co-located care of address is actually assigned to the mobile node itself, and now we'll see as to how the data path is created. So the IP packet sent by the correspondent node has the source address as the correspondent node's address, the destination address as the mobile node's address, and the packet is sent to the home agent. The home agent now again does the encapsulation, so it has its address as a source address, that is the home agent's address, and the destination address here is the co-located care of address, which is the address that has been assigned to the interface, and this address normally is actually obtained dynamically with the help of the DHCP protocol, right, or the DHCP server, right? So this we should all remember. So now whenever this packet is sent through the virtual pipe, mobile node receives it and it tries to decapsulate and get the original receiver's address or use it subsequently, right? So this is the difference between the data path for foreign agent based care of address and the data path for co-located based care of address. Hope this concept is clear. So this is just an overview of whatever we understood earlier. So I told about a home network, a router which behaves as a home agent, again a router here which behaves as a foreign agent. This is the foreign network where presently the mobile node is available. This is the internet. So the correspondent node through the router via the internet tries to forward to the home network. The home network creates a pipe and sends it to the foreign agent. The foreign agent subsequently delivers it to the mobile node in the foreign network. So this flow is actually given here in points 1, 2 for the tunnel, 3 to actually deliver it from the foreign agent to the mobile node. And when the mobile node is trying to respond back, it tries to directly respond with the correspondent node. Right? Fine. Now, handoff. See, we would have come across this term handoff frequently. What do you mean by a handoff? And when do we experience this handoff? That is very important. So when is it required basically? Whenever we feel that when we are in a particular network and when we are trying to move from one network to the other, probably the signal strength becomes very weak and we feel that we are not able to receive the voice or the data in an efficient manner as we had when we were in a particular network, right? So whenever a signal becomes weak, it is understood that there is a handoff that is required to find a network which has a better signal strength in order to support data transfer without any hindrance. Okay. So the typical phases that involve in handoff is first we'll have to measure the signal strength to find out whether it is weak or it has sufficient signal strength and decide where and when to do this handoff, and then we'll have to go for establishing a new connection. Right? So there are certain classifications for this handoffs that could basically take place based on whether it is a mobile that initiates this handoff or a network that initiates this handoff, or a mobile that evaluates whether a handoff is required, or a mobile that assists the base station to get a handoff in order to have the better signal strength for connectivity. Right. So let us understand the difference between all these 4 types of hands-off. So one is mobile initiated handoff. So the term clearly defines that The mobile node here measures the signal strength and decides the handoff. So that is what you call it as a mobile initiated handoff, since the mobile has initiated the handoff after measuring the signal strength and coming to a conclusion that the signal strength is less. And the next is about the mobile evaluated handoff. So here, see, the mobile node supports the base station in making a decision. So that is why you call it as a mobile evaluated handoff, that the mobile node measures the signal strength and the base station now decides the handoff. Right? So the difference between mobile initiated and mobile evaluated should be very clear. Fine. Coming to the network initiated handoff, it's very clear where the base station will measure the signal strength and decide where the mobile node should be handed over to at that point of time. Right? So the complete decision and discretion of connecting the mobile node to a different base station purely lies with the base station. That is what you call as a network. Fine. Coming to the mobile assisted handoff, the mobile node assists the base station in network initiated scenario by measuring the downlink signal strength, and then it decides the handoff. So it just measures the strength of the signal and then tries to decide about the handoff that is going to take place. So these are the 4 classifications of hands-off, and we understood when a handoff is required and how basically a handoff takes place. And there are again 2 types of hands-off, handoffs. One is hard handoff, the other one is soft handoff. It's very simple to differentiate between hard handoff and soft handoff with a simple phrase that is made for it. So when we tell about hard handoff, it's nothing but break before make. When you talk about soft handoff, it's nothing but make before break. Right? Soft handoff is slightly safe, while hard handoff is just going to experience little hindrances. We'll just try to understand how this basically takes place to clearly know what is the difference between a hard handoff and soft handoff and what would be the pros and cons of each. Right? Coming to the hard handoff, as I said, it's break before make. So at any point of time, there's going to be only one active connection. Right? So mobile node will be actively connected to only one of the base stations. Right? So if you see to the scenario here, the mobile node is here. The base station that is presently the mobile node associated with, and then the border, you can notice that the mobile node tries to, probably you cannot see in this part, yeah, so this is the next base station. So when the mobile node, let us see in this part of the figure, so when the mobile node actually is towards the border or at the end of the cell region of the first base station with which it is associated to, it tries to break its connection with this base station and establish a connection with a new base station. Right? So this is what I call as break before it makes its connection with the second base station or a new base station. Right? So this is actually called as a hard handoff because it takes a risk of confidently assuming that it will get its connection with the next base station and have its association further, right? The next is soft handoff. As I said, it is a make before break, so it's a smart way of doing. Like you hold the old one and try to get connected with the new one. And once you are confident that the new base station is sufficient for you to get the better signal strength, you disconnect with the old base station, right? So that is what is typically given in this particular scenario, right? So the mobile node, it holds its connection with the previous base station, establishes its connection with the new base station, and once it is confident that the connection is established and it's able to go ahead with its communication, it tries to delinquish with the previous base station, right? So this is the difference between a hard handoff and a soft handoff, right? So again, in fast handoffs, at times it is required that we need to support even a fast handoff, because if at all you need to reduce the delay, and if delay cannot be compromised, we need to go ahead with such mechanisms. So that is called as a fast handoff. In fast handoff, again, there are 2 versions. One is a pre-registration handoff and the other one is the post-registration handoff. So in pre-registration handoff, the registration with the home agent takes place before the handoff while the mobile node is still attached to the old FA. This is similar to the soft handoff. And this is a post-registration handoff where the registration with the home agent takes place after the mobile node is connected to the new foreign agent, right? So this is about the fast handoffs and its methodologies, right? So see, we try to understand how Internet protocol is extended to support mobility with the help of mobile IP, where we saw that the same permanent IP address is used, but then we try to add additional information and maintain the information in the form of routing table, and we were trying to support mobility. And that was actually understood with the help of care-of address, and we understood about different types of care-of addresses that we have used. Above all, mobile IP also has certain issues, and that mainly is on security problems. So let us understand where the security problems come from. Right? So see, we know that we are trying to rely on a foreign agent. A foreign agent may be a malicious node, so we do not know if it is an authentic node or a genuine node for us to share the credentials when we are in a foreign network. At times, like we may also have a tunnel hijacking that takes place, so it is also a drawback, a security issue. And the registration request itself at times could be by a malicious node which may not be in a position to differentiate. So that is again an issue that we may experience with the mobile IP. And if the authentication with the foreign agent is problematic, the foreign agent typically belongs to other organization. So that is the main highlight about this. So these are certain security issues that the mobile IP experiences. Right? So with this, let us now try to go ahead with the next layer, that is your TCP, and we'll see how TCP is extended to wireless. Right? So as I told you in the initial discussions, normally TCP assumes congestion if the packets are dropped. Right? Anytime a packet is dropped, TCP thinks that it is because of congestion, but this may not be true in a wireless network, because wireless network may experience a packet loss because of some errors that could happen in the medium while transmission takes place in open air, right? So generally whenever there is a drop in packet, what we do is we try to go for retransmission. But when we try to do more retransmission, the tendency is we are not trying to utilize the bandwidth in an efficient manner. We try to waste more of the bandwidth in retransmitting the packets whenever it is lost in the medium, right? And this mobility itself is expected to create lot of packet loss, right? Because when one mobile node roams from one access point to the other, by the time it gets connected, there are chances that it could lose some packets. Again, this mobility is going to be one of the reasons for packet loss. So TCP need not have to generalize that packet drops would be due to congestion. It can also be because of some transmission errors and because of the mobility that is going to be supported by the wireless domain, right? So having come to know about this, again there are certain solutions that are actually proposed to extend the TCP to wireless part. One is at the link layer level, so which we call as, the link layer solutions, which is called as a Snoop TCP. The next is a split approach, where we'll be trying to split the network into two. One is a fixed part of the network and the other one is the mobile part of the network. So that is called as an indirect TCP and the mobile TCP. And the end-to-end solutions we'll try to understand with explicit link notification message and TCP's selective acknowledgement scheme, right? So these are certain approaches that we are going to understand in the further discussion. Right. So the classical TCP is improved in all the cases that we are going to discuss, and we'll see how this improvement is brought in and how they have overcome the drawbacks that exist when they'll have to typically use the TCP that has been drafted from the wired network, right? So this indirect TCP is the first version that we are going to understand. So indirect TCP, what it does is it segments the TCP connections into two distinct connections. One is the wired part of the connection, the other one is going to be the wireless part of the connection. So the wired is going to be the standard traditional TCP, and the wireless is going to be the optimized TCP protocol, right? So as I said, the TCP connection is split into two, right? So this is a foreign agent, and this is about the wireless part, and this is the wired part. So the foreign agent can also be called as an access point, where in this scenario we can notice that this access point is the one that acts as a proxy for the mobile node. So what actually is done by the access point here as a proxy is, every time whenever a packet is buffered from the correspondent node towards the mobile node, I mean whenever it is transferred from the mobile node to the correspondent node to the mobile node, the access point here just tries to buffer it and try to give an acknowledgement to the correspondent node, and whenever the packet is delivered successfully. So we can notice that the mobile node gets the acknowledgement from the access point alone, right? So the host that is in the fixed part of the network does not notice the characteristics of the wireless part at all, because the foreign agent or the proxy or the access point over here tries to give all the acknowledgements on behalf of the mobile node by buffering and trying to transmit whenever in case there is a loss in the packet in this part of the network, right? So if you notice, though there are certain advantages, there are certain disadvantages also, right? So when we look at the advantages, there is no any change in the fixed network that we'll have to do. So no changes for the host, so the TCP protocol as such can be used. And all current optimizations with the TCP still work between both the foreign agent and the correspondent node. And we can also notice that the transmission errors on the wireless link does not propagate into the fixed network because of the strict partitioning that we have seen. So this is an advantage, because like unnecessary dissemination about the loss of packets and so on is not actually intimated to the correspondent node every time, and again the full length transmission is also not going to take place. And yes, since the access point is going to do the transmission of the packets in case there is a loss, we say that fast retransmission of packets is possible, right? So these are certain advantages about indirect TCP, but there are certain disadvantages too, right? So when I say disadvantages, one is about the loss of the end-to-end semantics, right? When I say an end-to-end semantics, see, we discussed in the previous points about the advantage where the transmission errors on the wireless part is not propagated to the fixed part. So there is a complete segregation between the wired network and the wireless network, and hence the end-to-end semantics, the end-to-end acknowledgement between the correspondent node and the mobile node is not available, right? So this is becoming a big drawback. And of course, since the data is being buffered at the access point and forwarded every time, there is a larger latency that can be experienced. So we call it as a higher latency that is possible to happen. And trust on the foreign agent is again a big part. We need to actually take this also into consideration, right? So the advantages is there is not much changes that will have to be extended with the fixed part of the network, and certain optimizations in the mobile part is alone sufficient, and the errors do not propagate towards the correspondent node and the mobile node, and retransmissions also takes place in a quicker manner. At the same time, the drawbacks, the end-to-end semantics is lost, latency, the delay is actually increased, and the trust on the foreign network or the foreign agent is going to become a big question mark. Okay, and the next is about the Snoop TCP. See, we saw in the indirect TCP that the drawback is the TCP connection is being segmented into two connections, and this basically loses the original end-to-end semantics, right? So to overcome this drawback, the solution that they have proposed with snooping TCP is a transparent extension of the TCP with the foreign agent. They try to extend the wired part transparently towards the foreign agent, and all the packets are buffered at the foreign agent, where the foreign agent is expected to be closer to that of the mobile node, right? Because of which the retransmission could take place in a faster manner, and it could also be in a local manner. The only role of the access point here is to just snoop, right? As it did in the indirect TCP, it does not provide any acknowledgement on behalf of the mobile node. Right? It just snoops and just goes through whatever is happening between the mobile node and the correspondent node. Right? The lost packet on the wireless links is retransmitted immediately by the foreign agent with the help of local retransmissions. And of course, the acknowledgements are exchanged between the correspondent node and the mobile node. So here, the end-to-end TCP connection is actually experienced. So the drawback that was prevailing in the indirect TCP is overcome in the snooping TCP, right? So as I said, the advantage is end-to-end semantics is reserved. The correspondent node does not need any change. The foreign agent alone has to be enhanced. So the foreign agent here is just going to be enhanced to do the local retransmissions in a faster manner. That is the enhancement that has been done over here. It doesn't do any acknowledgement or provide any acknowledgement on behalf of the mobile node. And coming to drawback, as I said, security, because trusting a foreign agent is very, very difficult. So that needs to be a major concern. And better encryption scheme is essential for snooping and buffering data, because again, snooping of data may be by even an unauthorized agent, right? So this is again a drawback that we will have to be addressing in the subsequent methodologies, right? So the third methodology is mobile TCP, right? So we saw that the problem in the wireless domain often occurs due to loss in connection for some small period of time, right? See, whenever we see even when we try to talk over mobile, we can notice that probably there will be a break in signal for a small period of time, and then probably we'll try to get the connection again established, right? This is generally because of the less signal strength that could be there, just because we, the users, are behind a large building or a tall building, or because of certain hindrances that could happen in the channel, right? So these problems which occur for a small interval of time should not actually become a big hindering point for our communication, right? So to overcome this, mobile TCP is proposed, where the procedure is the sender needs to be informed in all such cases whenever such a loss in connection is experienced, even for a smaller period of time. So in order to intimate the sender about this, a host called as a supervisory host. A supervisory host is typically a node in the wired network that will basically control all the access points, and this supervisory host is actually expected to handle this situation and try to intimate the sender if at all there is going to be a loss in connection for some small interval of time, right? So what happens here is mobile TCP basically splits typically like our indirect TCP, where you have one part which is the unmodified TCP, where a fixed network is connected to the supervisory host, right? And the next part is called as the optimized TCP, where the supervisory host is connected to the mobile node. So you have two parts. One is the unmodified part, that is the fixed part. The other one is the optimized TCP, which is going to be the path that is being created between the supervisory host and the mobile node. So what is the role of the supervisory host? As I said, it's just going to monitor all the packet transmission between the mobile node and the correspondent node. So this is typically like the access point or the proxy in our indirect TCP. But one difference is it's not going to buffer or cache any information or data that is being transmitted between them. And similarly, it is not going to do any retransmission locally between the mobile node whenever it tries to have any loss in the connection, right? But what it does is, if at all, if it finds that there is a loss in the wireless link, it will send an intimation to the sender to retransmit packets in order to maintain a end-to-end semantics. This is the main advantage of the supervisory host. Okay, so if the supervisory host does not receive an acknowledgement from the mobile node, it assumes that the mobile node is disconnected. So what it does is immediately it will send the sender window size to 0. I'm sure all of us would have understood about this in the TCP when we were trying to study about a slow start algorithm and other exponential growth, multiplicative decrease, and so on, right? So here, the moment the supervisory host senses that there is no any acknowledgement from the mobile node, it understands that there is a small change in the signal strength. So immediately it sets its sender window size to 0. What is the indication of setting the sender window size to 0? The sender is informed that it cannot go ahead sending any more data unless it gets a signal from the supervisory host, because the strength of the signal is weak. Right. On getting to see the sender window size, which is set to 0, the sender automatically goes into the persistent mode. So once the supervisory host detects the connectivity again, it reopens the sender window to the old value, when the continuation takes place and the data transmission proceeds. Right. So this is how the mobile TCP is devised, and improvisation has been done on the traditional TCP to support mobility and to take care of maintaining the end-to-end semantics. So coming to understand the advantages and disadvantages, as we clearly understood from the definition and from the methodology in which mobile TCP is working, we understand that the end-to-end semantics is maintained, and it supports efficient handover, of course, because it just tries to monitor the signals, and the delay is also reduced, that is, the lesser delay is experienced. And whenever you try to have an efficient connection or a communication that is established, naturally it will reduce or avoid more retransmissions. This is again the main advantage about our mobile TCP, right? What is the disadvantage? See, we said end-to-end semantics is maintained. End-to-end semantics is maintained, the mobile node and the correspondent node get to know what is happening on both the sides. So naturally, whenever there is any loss in the wireless link, it will be propagated into the fixed part of the network also. This is the drawback which we were not experienced in the previous methodologies. But then here, since they have the semantics maintained, of course, whenever there is a loss in the wireless part, it will be propagated into the wired part of the network. Right? Okay. So the next variation is about explicit loss notification. See, the very meaning of this itself is clearly evident. What do we mean by explicit? Trying to outright tell about any loss, and the notification that we are going to send is what you call as explicit loss notification. In case there is any loss in packet, we are just going to send a notification explicitly to the sender, and the sender is about to actually take care of retransmitting whenever it tries to get a signal back. Right? So why is that we need to have this explicit loss notification is? So the problem with TCP lies in the fact that it does not know the exact cause for the packet loss, and hence has to invariably assume that it's always because of congestion. So this I have been telling you repeatedly. The tendency is every time when there is a loss, they think that it's because of congestion. So in this situation, ideal TCP, what it will do is it will simply retransmit the lost packet without using any congestion control mechanism. Right? So what is that they do here is simply try to detect the loss at the mobile node. And when they detect that there is a loss at the mobile node, they send an explicit loss notification to the sender. So the sender, what it does is, it does not reduce the window size on receiving the explicit loss notification, as it understands that it is not due to congestion. So it just tries to retransmit, and it clearly understands that there has not been any congestion, and it is because that the packet is lost, it has to go ahead retransmitting. Right? So this is the key concept of explicit loss notification. Right? And next is about the selective acknowledgement. It is the TCP that tries to use a selective acknowledgement. See, if even a single packet is missing, right, we just go ahead trying to send the whole sequence of the packet beginning at the gap, and this actually lands up with wasting lot of bandwidth. Right? So what they did is they went in for having only a selective acknowledgement, and this actually reduced the buffer space, and efficiency, if you see, it has become very high. But then the only drawback is, like we need to have more complex software in order to notice which packet is being retransmitted and only acknowledge the selected packet. Right? And again, more buffer is needed at times to buffer them, because we try to acknowledge the packet that has been selectively sent. Right? So this is about TCP's selective acknowledgement. Now this table will give you a summary, right, with all the different approaches that we understood. So we understood about the approach. It is nothing but the mechanism. So for example, with indirect TCP, we said it's splitting the connection into two. One is for the wired part and the other one for the wireless part. And we understood the isolation of the wireless link as the advantage. And the disadvantage is it loses the semantics, that the end-to-end semantics, and the latency was higher. Likewise, we understood about different approaches with respect to TCP, their advantages and disadvantages. Right? So let us summarize all the key concepts that we understood in this session. So we started with understanding what wireless internet is, and we also got to know about the issues that are prevailing whenever we need to actually extend this to wireless part. And we took it in 3 different layers. One is in the network layer. So we went in for a mobile IP, which was the solution proposed at the network layer. Then we went in with the transport layer, and we tried to say about the methodologies that have been proposed, like indirect TCP, Snoop TCP, mobile TCP, and so on. And finally, with respect to the application layer protocols, of course, since bandwidth is the constraint, there's a protocol that has been proposed, which is a wireless application protocol, which will be discussed in the next session. Right? So we again understood about the other issues like compatibility, transparency, and the scalability. We understood the core concept of mobile IP, the various terminologies, an example scenario, the difference between a co-located and a foreign agent-based care of address, the way in which the data transfer takes place to the mobile node and from the mobile node, right? And how encapsulation basically takes place and packet being tunneled between the home agent and the foreign agent in 2 different methods and approaches. This is a general overview. Again, we understood about the handoff mechanisms, the classifications, of course the differences among each of these classifications, the difference between the hard handoff and the soft handoff with a simple scenario, and what is the need for a fast handoff, and again its types, and what are the general issues that mobile IP will experience, such as tunnel hijacking, or a foreign agent being a malicious node, or a registration request that comes from a malicious node, and so on. And then we started discussing about the TCP part, which is extended for the wireless network. And we clearly understood as to the tendency of TCP to actually assume every time whenever a packet is lost as congestion, which may not be true with the wireless network. So we said that it can also be because of the transmission errors and because of the mobility. And we again understood about the various approaches, about the indirect TCP, its advantages, the disadvantages, the snooping TCP, its advantages, disadvantages, and how the drawback of the indirect TCP is actually addressed by the snooping TCP in maintaining the end-to-end semantics, and about the mobile TCP, how a third party, that is a supervisory host, is assigned to monitor the packet transmissions, and where it was not trying to do any acknowledgement or whatever it is. The simple task done by the supervisory host is to actually intimate the sender whenever it senses there is a signal loss, right, or some disconnection that is experienced in the connection, or for some small periods of time, right? And again the advantages and disadvantages. And then we understood what explicit loss notification is, about the concept of how explicit notification is sent, and what a selective acknowledgement is, right? And we also went in through the comparison of different approaches for a mobile TCP. So the core concepts of extending the internet for mobile users is discussed in this session. Thank you. In continuation with the discussion we had on wireless internet, we tried to understand the improvisations that were proposed with respect to the network layer, and the transport layer. Now coming to the application layer, we said like the HTTP and SMTP are the traditional protocols that are being used in the application layer. So to extend to the wireless part, we have this wireless application protocol, which we generally call as WAP, right? So the main is to empower the mobile users with their wireless devices in order to easily access and interact with information and the other services from the internet, right? So it is basically a standard that is created by the wireless and the internet companies in order to have the internet access from the mobile phones or the cellular phones. So to do this, a simple lightweight browser is being integrated in all the handheld devices. So for example, like the Ericsson, the Motorola and the Nokia, they all were a part of this forum to actually create such a facility. So this is a generic internet model, so where we have a client-server model. So the web browser basically is used to send a request for a particular URL, and the web server tries to give a response in the form of HTTP response. Right? This is a typical internet model. Now coming to look at the WAP architecture, apart from the client and the server, we can notice that there is a gateway that is playing a major role as a mediator between the client and the server. So whenever there is a request from the client, the gateway tries to do the encoding part, and based on the request, the data, whatever is acquired from the web server, is filtered and it is given back through the gateway to the client. Right, so let us understand the steps in which the client and the server interaction basically happens. Right. So as we saw in the previous architecture, the gateway acts as a proxy server. So that is going to mainly take care of all the protocol translation and ensures the optimized data transfer that is going to take place over the wireless medium, which has a constraint of bandwidth. Right. So it basically is going to play a role like a convergence point between the wired and the wireless domain. Right. So whenever a handset or a client generally gives a request, the gateway converts it, and the HTTP request is shared to the original server. And we have the filters which converts this HTML content into your WML, that is a wireless markup language content, which is given back to the gateway. So how this WAP works, right? So the user basically selects an option on the mobile device that has a URL with WML content, right? So the phone sends the URL request via the network to the WAP gateway using the encoded WAP protocol. The gateway translates this WAP request into a conventional HTTP request for a specified URL, and then it sends it on to the internet. Now we can notice that the web server picks up that request, which is in the form of a HTTP request, and the server processes the request just as it would for any other request, and it tries to give a reference to a static WML file and then delivers it, right? So if in case that is the CGI request, of course it is processed and the content is returned as usual, right? So the general procedure is the request from the user is actually handled by the gateway, which is nothing but your WAP gateway, where all the conversions basically takes place. And this gateway acts as a bridge between the client and the user. That is nothing but the wireless and the wired part of the network, right? So looking at the reference model, typical to the internet model, of course, it has different layers, right? So you have the application layer, the session layer, the transaction layer, security layer, and a transport layer. And this is going to be all the bearer services at the lower level, right? And as I said, WML is the language being used. With regard to the different responsibilities of the layers of WAP, the first is about the application environment, that is WAE in the application layer, which includes a small micro browser environment. It takes care of addressing and maintaining the standards and developing a similar script called WML script, which is just like a JavaScript. And coming to the session protocol, of course, session management is the main task. So it actually gives the functionality of the HTTP in a very optimized manner. And next is about the wireless transaction protocol, which provides a lightweight transaction-oriented task. And you have the transport layer security, of course, authentication, data integrity, and creating a secure socket layer is a very typical task, similar to that of the WWW model, that is your World Wide Web model. So security aspects are taken care. So I'm sure all of us are familiar between the difference between authentication and encryption. Of course, authentication is the first level to ensure authorized access, and subsequently we go ahead having hard security algorithms to ensure secure transmissions. And the next layer is your transport layer. Transport layer, if you notice, WDP, the wireless datagram protocol, takes care of all the TCP and UDP functionality as in your internet model. And in addition, it again makes use of a wireless control message protocol. So I didn't know how many of us could remember about the role of ICMP, which is nothing but your Internet Control Message Protocol, which was actually a support protocol for your IP in your network layer in your traditional TCP/IP protocol suite, right? So there ICMP was actually trying to generate the control messages, which was like a support for the Internet protocol. Likewise here, wireless control message protocol is a message protocol that additionally plays a role in the transport layer to take care of all the control message communications, right? And as I said, WML is a markup language that allows the text portions of the web pages to be presented on all the cellular phones, and of course the PDA is via the wireless access. The key features, if you notice, it will support text and images, it enables the user interaction, supports navigation, of course content and context management is also a okay. So app is an extension of your traditional wired protocols, which is actually supported for the wireless patch. And we understood the purpose of WAP, the comparison with the internet traditional model architecture with WAP architecture, and what is the main role of the gateway, that is your WAP gateway, and how it acts as a bridge between the client and the server, between the wireless and the wired part, and what is the typical role of the WAP, and the reference model and its protocols. So we can just have a look at the similarities between the protocol stack of internet and the WAP model, right? And again, the responsibility of each layer is what we have gone through, right? So